If one of the students is randomly selected, find the probability that the student has had sex with one partner or 4 or more partners. Okay, so this whole paragraph before just describes where the data came from. It's from a 2009 Canadian Journal of Human Sexuality study. They go on to tell you how it was comprised, but the final point of the question here is this part here, where it says, if one of the students, so let's first underline that, one student is being selected, right? Randomly selected. Find the probability, so we're looking for probability, that the student has had sex with one partner or 4 or more partners. So when we look at the table here, we see that there is one partner here and 4 or more partners listed here. So we have that data listed in the table. Now, in order to do a probability problem like this, we want to pay attention to how many members were being selected or how many people or subjects are being selected in the study, and then look at whether they're asking for probability or not. So it's one of the students is randomly selected, find the probability, and then they go on to say that the person has had sex with one partner or 4 or more partners. This word "or" here is very important because this "or" indicates addition. Now, 4 or more is just the name of this category, so don't confuse that extra "or" there. So it's one partner or 4 or more partners, right? Okay, so it's an addition rule of probability. So let's write down the formula. The probability of one partner or 4 plus partners. All right, so the probability formula says probability of one partner plus probability of this guy, the 4 partners or 4 or more partners, minus the probability of both one partner and 4 plus partners. Okay, now we can see that this actually doesn't make sense. There's no way you could be in the category of number of partners 1 and number of partners 4 plus, because either the person has had just one sexual partner or they've had 4 or more sexual partners in their past. So there's no way that it could be one subject being into both of these categories. So we're going to say that this is a case where the 2 categories are mutually exclusive. A member of one category cannot be a member of the other. So if you're a member of this category, you're not possibly a member of this category. So that means that joining them together is impossible. So we'll put a 0 there. So 0 probability of a member being in both of these categories at once. So if it's mutually exclusive, that's nice. It just means we just have one fraction added to another fraction. We don't have to worry about this third fraction that has to be subtracted off. Okay, so now we just simply fill out this fraction. It would be the number of subjects with one partner over the total. And the next one is the number of subjects with 4 or more partners. And that'll be over the total. Okay, and at that point, the final thing then is to simply fill in the numbers for our fractions. Let's start with this one, the number of subjects with 1 or more partners, right? Or one partner, pardon me, not 1 or more, just 1. So number of partners 1, the total number of people in the study with that was 1,068. The grand total, the big denominator, is 2,145. We'll add that to the number of subjects with 4 or more partners. So 4 or more partners is this row, that's 462. And then the grand total, 2,145. And since that last fraction was 0, we can just add these two, divide, and get our solution. Okay, so let's do that then. We'll have 1068 added to 462. Since they have the same denominator, I'll keep that denominator. And my answer will be 1530 divided by 2,145. And when you do that, you end up with the answer 0.713, or basically 71.3%.